Hey everybody, welcome to the channel. Today I'm going to use the PCAN software to troubleshoot an issue that I came across on a bus recently that was something new that I hadn't seen before, and I had to really dig into the messages that go between multiplex modules and just confirm that things were supposed to do what we thought they were going to do. And I'm going to show you what the output of the module looks like, and then also how I use the PCAN Explorer software to troubleshoot to confirm that the program was running correctly and the issue ended up being at the module and not something else. So if you follow along, I hope you enjoy the video and you learn something new. And if you have any comments, feel free to leave them at the bottom and ask any questions, and enjoy the video. So just to kind of go over quickly what I'm talking about, this particular box here is called a ZR32B, and this component on the vehicle has all the programming in it to control all kinds of things in the vehicle. In our particular problem that we were having, fans were not running at the right speed. There was no control over the fan speed for the passengers area, and the component that controls that is called the MUX2B in this case. It's essentially it's a really fancy relay board inside here that controls, turn things on and off, and gets inputs, and it sends them to the ZR. So it does all that through a little communication plug here in the bottom corner. Let me show you, it's right here, and it's over a CAN line. So we can look at it if we have CAN software, which I will use in the video today. And this troubleshooting, the purpose of doing the troubleshooting was one of the outputs, I believe it was output on the E-plug here, is supposed to send out a signal to control the fan speed by turning the signal on and off really, really fast. And I'll show you an example of that coming up. And our issue that we had was that it wasn't changing the fan speed, even though everything said on the vehicle side that it should have been. So we had to do a bunch of troubleshooting, and ultimately one part of that troubleshooting involved seeing if the signal was going to that module and was actually changing. So if the signal was changing at the module, then the module should have been changing the output. I'll show you how we get to that point here shortly. So here's an image of the signal that we're looking for. To come out of the node, you can see the signal changes very rapidly on and off. Each one of these divisions is 100 milliseconds of time, each one of these square blocks. The problem is the signal we have coming out of the bus now looks like this. It's just a flat line. A meter lead came off there for a second. That's why it dropped down. But normally, when we were testing it, it's up here at the top, like you can see. And that flat line is only one speed, and it's not adjusting like it's supposed to. So that's the problem we need to figure out, and the problem that we're going to do some of the testing on. So before we jump into using the software, I just need to give a shout out to the folks over at PhiTools, where you can get the hardware and the software. They contributed a little bit to this video and subsequent videos that I'm going to make. I'm also going to mention them. They've been very helpful. They're getting software to try for people to actually try on their own for a period of time. And they're also very helpful when it comes to technical support if you have any issues or questions with the software. So for sure, check them out. I'll put a link in the bottom of the video. And I really appreciate them helping out a little bit on these videos to go forward, since it's just me as my little company that I have. Alright, so as far as the main hardware goes, there's the PCAN adapter, and I have a serial port with some two connectors that stick out of the serial port, essentially, that I can plug in behind the plug on the node, so I can read the CAN data that's going across the network. To figure out what's going on. So really you need the PCAN adapter, and you can get RS-232 serial port connector. You can get one of these serial port adapters that will plug right into the PCAN adapter, and you can put your CAN high and CAN low and the ground connection to really BNC clips, alligator clips, whatever you need to attach them to, and then essentially on the connector itself on the module here on the back, you'll just take those two clips, those 2 points, and you'll probe right into the back of the CAN lines here with everything connected and running. So you can do the tests that we're going to talk about here shortly. All right, so let's jump right into this here. Here's creating a new project. I have to add a CAN network to the project. So you can see here I have the USB adapter. Using the 250 kilobit per second baud rate actually isn't going to work on this bus, so I have to create a new one. So under here we can create a new 125 kilobit connection first, because that's going to be the first step, because without the right speed I'm going to be not going to get any data. So I just named it ZR-CAN 125. It doesn't really matter what you call it. I put down the kilobits per second. You can select the option there. That's one of the pre-configured ones. Hit OK, and then you save that network connection. And then when I go back to the screen again and refresh it, I'll see the ZR-CAN 125 kilobits. The connection I'll rename here just so it looks nice on the main screen. And then the protocol is CAN. So now you can see on the screen there is a whole bunch of CAN data coming through. I don't know at the moment what really any of this means. So we're going to have to do a little bit of plugging and unplugging things to see what changes. And so from there, that's how we'll determine which module is actually communicating on the network. All right, so what I did here was I unplugged the module I was looking to try to troubleshoot. And when you unplug the module and you scroll down to the bottom of the screen, you'll see now there are some modules that are not, there's no counts going up anymore. So module 1AC, 1AD are no longer increasing in counts. So that tells me that those 2 particular CAN IDs on the left here are for the CAN module that I just unplugged, which is the CAN module I'm having the trouble with. So I want to be able to monitor the data that comes out of those. So what I'll do is I'll create a filter. Here at the top, I'll call it node 8 because that's the number that they call it in the vehicle. I'm going to put in here, add a filter for node 8, which is 1AC and 1AD. So you can see from 1AC to 1AD is my start from and to. And then I'll hit OK. And then I can go back and plug the node back in, which is what I'm doing right now. Nothing's happening on the screen. As you can see, none of the other data is coming through either. So all of these other CAN frames are not showing anything because I have the filter on at the moment. So it's a really nice feature to be able to use the filter to filter down exactly what you're looking for. All right, now that I have the node plugged in, I will clear all of the messages that were coming through so that now I can see only the ones from the node that I'm looking for. So in this particular case, 1AC and 1AD are the 2 nodes that are being filtered out. And I can see just the data from those 2 nodes. For some reason, there was no actual data coming through, it appeared, but then all of a sudden it started to show up. Now you can see the data fields have all changed from the FFFF values to actual real values. Usually when there's FFFF in each one of those bytes of data, it just means that it's just a placeholder. There's nothing actually being transmitted that's useful. All these other values are pretty much useful values. So from here, watching this data, I can actually go up to the front of the bus and I can control the fan speed and look to see if anything is changing, or see if I adjust the interior temperature, if anything actually changes on these values, so that I'll know that the messages that are getting to the node are in fact updating, which means that the output at the node should be updating. So what I did here was I had somebody go inside and adjust the fan speed. There's a fan speed switch that goes into this node, so I can monitor on the data portion of the CAN messages that there's actually something happening, like it's picking up a signal, something's changing, a switch is going on or off. So if you watch closely, you should see that the beginning part of 1AC, you have AA6A when the fan speed switch is pressed up, and AA2A when the fan speed is pressed down. So the second byte of data, 6A and 2A, are actually being picked up by the node and transmitted over the CAN line back to the ZR, which is important to see because that tells me that the node is actually taking in inputs and transmitting those inputs accordingly. And over here, I added a couple notes so I can copy and paste the what the different signals are doing. So later on, if I have to go back and double check or look at another node for the same inputs, I have something to compare it to. So I just put those notes inside. And then the next thing we realized was that the fan speed wasn't adjusting with the switches, so it was only being adjusted if I changed the temperature in the front of the bus. And then when you change the temperature up or down, it would adjust the fan speed. So here I'm just making another note that 1AD, I'm putting down the bytes that change. So you have 88 when the temperature is set down, and 98 when the temperature is set up in this particular case. You can see that at the beginning of the data there, 88, 98. And then the next step was to try to find out what fan speed bytes are changing as the fan speed changes. So that's really what we're looking for, to see if we're getting any change that the vehicle is telling the fans to speed up or slow down. And so what I had noticed was that I wasn't seeing any change in the CAN frames, and so I started to think, well, maybe I didn't catch all of the CAN frames that go to this particular module. So in that case, what I decided to do is take the filter off and then unplug my module again and figure out if there was maybe another CAN frame that I was missing from this equation when I unplugged the multiplex node again to see which messages stopped transmitting. So in this case, I unplugged the multiplex node again and went back down through the list to see which CAN IDs were not transmitting. Now with the node unplugged, I go back over like I did before, and I can scroll down to the bottom of the list and see the cycle times, see if any of them are not changing anymore, and also see if the counts don't change. So I did find out that 1B0, 1B4, and 1B5 were from node number 6, which was a different node. So then I realized, well, there should be 3 messages because now a different node is showing 3 different CAN frames. So in this case, what I did was I went back and I plugged that node back in, plugged in the node 8 again, and then I'll clear all of the data and see if I can find which one is missing from my initial suspicion for node number 8 that I'm working on. And you can see now that the cycle time for CAN message 1A8 is not changing anymore either. So that is the missing CAN frame for node number 8. So I just went in and put down node number 8, so I have that available now to look at and make sure that I have all of the 3 CAN frames available to see what's changing or what's not changing. So go in and you can re-update the filters again to look for that 3rd CAN frame from node number 8. Here's editing the CAN frame, and since it was 1A8 was the frame, I ended up just adding a second filtered item with just 1A8 as the start and end range for the CAN frame. You can see here, or 1A8 to 1A9, because there is no 1A9 anyways, and they hit OK. And then I can go ahead and I'll be able to clear this out, be able to plug the node back in to make it communicate again. Clear the window, and now I have the 3 CAN messages coming from node number 8. So from here, now I'm able to change the temperature in the back of the bus at the top and see if the fan speed signal, there's some kind of a fan speed signal coming over to the node. Because when I change the temperature, the only thing that really changes is the fan speed itself. So I have somebody up front changing the temperature down, and then I'm watching closely to 1A8, which is that other signal I had not seen before, to see which bytes are changing, which data bytes are changing. And then from there, I'll be able to make notes of those data bytes just to confirm that there actually is a change. So when I had done this, I had realized that the data bytes at the end where it says 4050, those were the data bytes that were changing. Like you just see it change there to 5000. So what I did was I just went into my notes and put in some notes here to show what the different fan speeds are for the fan itself. And you can copy this whole data frame right out of here, and you can paste it right into your notes so you don't have to type everything out. So in this particular case, this was when the fan speed was at high. Then I had the technician change the temperature and actually lowered the temperature down. And in this case, it should slow the fan speeds down when he does that. So he's lowering it down right now, and then at some point, we'll get a change in the data frames. You can see it now just changed down to A000. So in that case, that's when the fan speed is low and the temperature is actually set high. So it's calling for heat in this case in the back of the bus. So from this, we know that the CAN is actually sending the right message or sending messages over to the node. But for some reason, the node is not responding at all. It's just not outputting a change in the output. You can see here I did various tests with different settings just to make sure something else in the data wasn't changing. But it was the last 2 bytes of data that were actually changing, the 4050, the 44A0, 4450, 44AA, 40AA. Those were all the changes that were coming over the CAN line. And I confirmed those same changes were happening on another node that did the same type of output as this one. And when I saw those changes, they matched up with the fan speeds. But fortunately, that node was actually outputting the correct signals like we saw earlier with the pulse width square wave going on and off, on and off. So using this data and going back and forth, I was able to fairly quickly identify that there was in fact a signal being sent to the node. The programming was working correctly. The node itself was just not reacting the way it was supposed to. Alright, so after going through this testing and confirming that replacement nodes weren't fixing the problem, and that data was actually being transmitted to and from this test node from the ZR, the program was clearly working. The CAN communications were clearly working. And what I ended up doing at some point, I had a thought in my head about what was going on, is I ended up taking this node from position 8, that where it was on the bus, and I moved it to position number 1, which had a working fan speed output. And when I plugged it into position 1 and reset the bus, the output on this node, E13 I believe it was, so on the diagram earlier, the output was sending out the correct PWM signal. So that tells me that there was nothing wrong with the node at all, and the program perhaps was not being set into this, because when you first plug these in, they're supposed to take an initial program from the ZR. So clearly it seemed like the program didn't get put into here correctly. I then moved the node back to position 8, and everything worked perfectly fine. All the signals came back, they were operating like they were supposed to, the fan speed worked, and so I had a thought then, let me do it to node number 6, which was also not outputting the correct signal as it was supposed to be. And when I moved node 6 into node 1's position and reset the bus, it was working in node 1's position, just like node 8 was. So I then took that node and put it back in node 6's location, and the output was working perfectly fine again in node 6's location. So in the end, we kind of figured that perhaps in this particular system, you need to maybe plug the node into a different location on the bus or a totally different CAN line, because node 1 is on a different CAN line than node 8 was on, and have it essentially reconfigure itself all over again in order to get the right base program working. Once we did that, everything on the vehicle started working normally again. And so it was an interesting problem that we came across. The PCAN Explorer really helped to make sure that the program was working correctly, because a lot of people don't have access to see what the program's doing. And it also It helps you just better understand how the system's functioning. So I hope you enjoyed the video. If you have any comments, please leave them in the bottom below. And once again, I'd like to thank Phi Tools for their support and the software and helping make this video. And please check them out if you need hardware, software, help using your hardware and software. They're a great company. They've been around a long time. I've done a lot of business with them. They've always been there when I needed them. And thank you for watching. See you again soon.